Okay, so where we really started the conversation in environmental geology was talking about systems. We said a system is made up of a set of components that interact with one another. Most of the time, a system is going to have a reservoir of some kind, and that's just going to be a component that holds on to something, some substance. An example is the ocean. There are many examples. Material or energy can pass from one component of the system to another. We call this a flux. Water evaporates from the ocean and is returned through rivers. And so up here to the left, we have the same simple system with a couple buckets, a pump, and a valve that lets water flow from the reservoir up top back into the reservoir at the bottom. And so here I've closed the valve so that we can calculate a flux. And if you watch carefully here, we're kind of coming up on 30 seconds there on the second hand, and we're passing that mark. Those are liters. And if we watch for a moment, the flux is about 2 liters per minute. It's actually a little bit higher than that, but for simplicity's sake, we'll just call it 2 liters per minute. Okay, so that's the flux in. Currently, there's no flux out at all, right? The valve is completely closed. But if we open that valve back up and allow water to start flowing again, it'll reach some steady state where flow in equals flow out. Okay, and so that's this last point on the slide on the bottom there. At steady state, a reservoir is not changing despite flux in and flux out. Okay, and so if a reservoir is at steady state, that means that the reservoir volume is not changing, but there is flow in and flow out. And so because of that state, we can calculate something called a residence time. And the residence time is just the average amount of time a substance spends in the reservoir. Okay, and so you can calculate that very easily. It's given there at the bottom. Residence time equals reservoir volume divided by the flux in. And since the flux in equals the flux out at steady state, you could use either one. Volume divided by flux in or volume divided by flux out. Okay, and so if we let time pass here in this video, I can speed it up a little bit. All right, so we're going a little faster now. So I've opened the valve and the water's flowing out, and it flows out pretty quickly at first. But as the water level decreases, in this system, gravity is creating a hydraulic force or hydraulic pressure really on the valve, and it's causing water to flow out. As the water level decreases, the amount of pressure there decreases, and so the flow actually slows down. And so you'll notice that as the water level decreases, it starts going down slower. And eventually it'll stop going down at all, and that point will be around 4 liters. Okay, and so if we calculate the residence time, given that, so about 5 minutes have passed now in this video. If we just run it forward, we could just give it 4 or 5 more minutes. Yeah, it's settling in right around 4 liters. And so since 4 liters is the volume and there's 2 liters flowing in per minute, the total, or the residence time rather, is just 4 divided by 2, which is going to be, we can type this out. So in this case, the reservoir volume at steady state is 4 liters, and the flux in we measured is 2 liters, so liters per minute. Okay, and since it's 4 liters divided by 2 liters per minute, the liters cancel out, and it's just equal to 2 minutes. Right? Okay, so the average amount of time that water is spending in this reservoir right now is 2 minutes. Okay, so we could do a variety of things. We could perturb the system in a variety of ways, and one of those ways would be to close the valve a little bit. Okay, and so as time goes on in this video, I believe I will walk up and close this valve a little bit. All right, so we're at steady state here. The reservoir volume isn't changing. Oh, I'm walking past the camera, it looks like. All right, let's just move it forward a little bit. Okay, so it looks like I've closed this valve a little bit now, and the reservoir volume is increasing. All right, and so as time goes by now that the valve is closed a little bit and not as much water gets out given a specific amount of pressure, the volume increases. The flow rate in is still 2 minutes. I didn't change the speed of the pump, but water is going to keep flowing in, and over time, if we give it 5 minutes or so, we'll reach a steady state again. If I just speed the video up, we'll go a few minutes into the future. Okay, still going up, still going up, still going up. Okay, it's not going up quite as fast now. Oh, looks like I opened the valve again. Okay. Let's see. So I think we get to steady state right around here, which if we count those lines, that's 1, 2, 3, 4, 5, 6 liters. Okay, and we know that the flow rate in is still 2 liters per minute, right? Because I didn't change the speed of the pump. And so the new residence time is going to be 6 liters, right? We can just change it, that number right there to a 6. And it's 6 liters divided by 2 liters per minute. And so now the new residence time in this system is 3 minutes for water in that glass jug. Okay, so that's residence time. We slowed down the flow out, and in response, the volume increased until the hydraulic pressure forced enough water through that valve going out to equal the flow rate in again, which happened to be at about 6 liters. All right, so we could perturb the system in a variety of other ways. If I open the valve again, which I believe I do in this video, I open it and the volume starts going down again. It's fully open, and so we'd expect it to reach steady state again at about 4 liters, right? Because that was the initial steady state that we had. If we were to turn the pump speed up, that would cause the volume to increase as well until, again, the flow out equaled the flow in for a given openness of the valve. Okay, that's pretty much all there is for systems, components, and steady state. We would call the fact that the flow rate out increases in response to an increase in volume. We would define that as a feedback. And so I'll record another video now about feedbacks.